Hello, my name is Denis, and today I wanna talk about NoSQL databases, system design cheat sheet. So, a few things about me. My name is Denis Larionov. I'm ex-senior software developer at Lamoda. I'm coding at Go and used to code at PHP. I have more than 7 years of experience in software development, and let's begin. So first of all, I want to speak about key value DB as an example of NoSQL database. In key value DB, data is stored as key value pairs. And the key is unique and is used to access the corresponding value. Such databases provide fast data access by key, and it's a main feature of such databases. As for examples, I can provide Redis and React. For use cases of such databases, it can be used for caching, so you can put some frequently loaded information in front of your database or web server to get it quickly. Also, it can be used for session management, so you can store session information about your user in such databases. And also like login and some user preferences. Also, it is good for counters and statistics, so you can store like retweets, likes, and some like rate limiter counters and etc. In such stores. Also, it is good for geodata and geolocation. So you can store location information such as geolocation coordinates and point of interests on map. Also, it can be considered as configuration storage. So you can store and update application and system settings. Also, I want to speak about document DB. So in such databases, data is stored in document formats such as JSON or XML. It provides flexible data schema, and it allows for storing and retrieving complex documents. It really excels where data can be semi-structured or its schema may change over time. For examples of such system can be MongoDB or CouchDB. And let's speak about use case of such databases. It can be used for content management, so it can efficiently store and manage content such as articles, images, video, and audio. And it's also pretty useful in like digital libraries and in content management systems like CMS. Also, it's widely used in analytics and reporting. So you can store diverse data and store generated data needs. So let's say you can store pre-generated report for your user in such databases. Also, it is good for user management and authentication. It simplifies user management. You can store roles and authentication in it. Also, it's widely used in gaming industry because you can store game objects, character settings, and player achievements in it. Accounting and task management systems are also good for storing in such databases because you can store like managing of tasks, projects, and you can store to-do lists in such systems. And documents can represent tasks as their related attributes. Also, it's used in Internet of Things, so you can store data from sensors and Internet of Things devices, and as they can store various types of data, and so on. Applications with evolving schema really need such databases because you can store it as a document. You didn't need a particular schema to store the data, and it's really good when you have such application to choose this type of database. So let's talk about Columnar DB. So what is it? In Columnar DB, data store in columns rather than rows. It allowing for efficient processing of large volumes of data and analytical queries. It has high read and write performance. It has also high scalability out of the box. Also, I should notice that it has data compression technique, which helps you to store more data with less memory assumption. As for examples for such databases can be Vertica or ClickHouse. So for use cases of such database it's really good for analytics and big data warehouses because like it has really high performance for read and write, and it's really useful for big data warehouses and analytical systems. And also it helps to process a big amount of data, which is also very helpful for such systems. Also, I can suggest using such databases in financial systems and trading. So you can store transactions, operation systems, operational history, and like quotes in such systems. It's also used for monitoring and audit systems. So the ability to store and analyze event and audit log data makes them useful in like security and monitoring systems. Also, it can be used for time series accounting systems and all time series related data. Also, it's good for real-time systems because, as I said, it has high read and write performance, and it is really good for processing transactions and like event processing of your system. Also, it is good for version control and archiving sized systems. So you can store different versions of your document in such a database and track different versions of this document, and also retrieve particular version of document when you need it. Also, I want to speak about White Column DB. So White Column DB stores use as data model based on column families. It provides a high degree of schema flexibility So column families and columns themselves can be dynamically added without changing the entire schema. And it's also scalable out of the box. It's really, I need to mention that it has the same use cases as Columnar DB. So that's why many people confuse Columnar database with White Column DB. So they have some similarities, but they have significant difference. And you should ask, what's the difference? The difference is in a way of these databases store the data. As for Columnar DB, it stores each column separately on disk. So each column has its own file. As for White Column DB, it uses a data model based on column families. So what is column family? As you can see in a picture, it's like example of column family. You can see row key. I think we can say we can speak about row key as about partition key. So it's all primary key in relational DB, for example. So for each row key, we have columns, and each column has its value. So column 1, it's like the name of our column. Column 2 is also the name, and each of these columns has its values, and all of it combining in column family. Also, each family can contain different columns, and data rows can contain different families. So, as you can see in the picture, we have personal info column family for one person, like with, let's say, with row key user 1, and we have like name and surname for him. And also we have different column family for address for the same user, and it has the same row key but different columns. Its address and his phone, and it's different column families which we can store on different parts of our disk or even on different nodes of our system. As for example, for such systems can stand Cassandra and ScyllaDB. So let's dive into GraphDB. Graph databases are designed to store and process data organized in graph structure. They model data as a graph, and where nodes represent objects and edges represent relationships between them. As for examples for such system can stand Neo4j and Amazon Naption. Use cases for such systems is social networks. It's really good for social networks. You can like storing connections of friends in social networks and other connections that you need. Also, it is good for recommendation systems because analyzing user preferences and relationships allows for personalized recommendations, including products, music, and movies, and it really improves personalization of different products. Also, it's good for geospatial data. So graph databases well suited for storing and analyzing geospatial data. It can be like maps, especially roads, and some locations. It is widely used in bioinformatics and genomics. So it can be used for analyzing genetic data, gene and protein relationships, as well as metabolic pathways. It is also used in fraud and security to analyze networks and connections and prevent fraud and enhance security of systems and applications. Also, it's used in network and transportation system analysis. So you can optimize relationships between you can optimize transportation roads and telecommunication systems network. Also, it's used in relationship management systems and network analysis. So it can be used both in sociological contexts, in relationships, analyzing relationships between some entities, and so on. Okay, let's speak about time series DB. So for time series DB, I can say that it's specialized on storing and analyzing time-based data. It provides efficient storage and fast access to ordered data. Also, it provides ability to store and analyze data over time. And it's really important for variety of fields where tracking, analyzing, and forecasting data changes are required. So, as for examples, we can consider influx DB and timescale DB. So, what is use cases for such databases? I can say this is collecting and analyzing data from multiple sensors and devices in real time. Also, it can be monitoring the performance of computer systems, servers, network, and applications. Also it's event and action tracking for security and monitoring purposes. I can add it is good to record events and audits, as well as to ensure data integrity. So, as for conclusion, each type of NoSQL database is designed for different usage scenarios and has its unique characteristics. The choice of a specific database depends on requirements of your project and the characteristics of your data, so you should choose it wisely. I should say that flexibility and scalability of NoSQL databases allow for efficient handling and of large volumes of data and modeling complex relationships. On the other hand, Relational DB provides solid guarantees of data integrity and reliability. Also, it's important to know that Relational DB provides ACID transactions, which NoSQL didn't provide. So, choosing between relational and NoSQL databases, you should consider requirements of your project, data volume, complexity of relationships, and usage scenarios. That's all. Thank you very much. I really appreciate that you're here today. Thank you. And here's my LinkedIn profile and slides. You can contact me. So, have a nice day.